Remember the rule of thumb? The slower the asymptotic growth rate, the better the algorithm. That is, as the size of a dataset S grows, the time of an algorithm to process that dataset of size S also goes up. The question is, by how much? We prefer that an algorithm has a slow growth rate, such that if the size of the data grows, it doesn't translate into a very large increase in time. So let's look at this graph of comparison of growth rates. We always keep saying as n gets large, n being the size of the data. Looking at n when n is small, we might be fooled into thinking a fast-growing algorithm might not be as fast as we think. Take the cubic algorithm, represented by the purple line and x's, and an exponential algorithm, represented by a dark red line and filled in circles. Clearly, we know the cubic algorithm is a much slower growing algorithm than the exponential. But if we take n to be 5 as an example, the time that it takes to process is much less in the exponential algorithm than the cubic. Now let's take a look at this. As we zoom out, or consider n being sufficiently large, the true nature of these algorithms start to show. We can clearly see now that the cubic algorithm, represented by the purple line and the x, is now going to be overtaken by the exponential algorithm, the dark red line with the filled-in circles. As you notice, it doesn't take n to be very large before the exponential algorithm starts to overtake the cubic. Therefore, we can clearly see that the cubic algorithm is a much slower growing algorithm than the exponential one. So it is in our best interest, when dealing with asymptotic complexity, to choose an n that is sufficiently large. We want to do this because as n gets large, the true nature of these algorithms starts to show. It doesn't help us when n is small because the true nature of these algorithms don't really show through, and almost any algorithm that we choose would do the job for a small data set where n is quite small. Put another way, the consequences of choosing an inefficient algorithm, one that is not asymptotically superior, when the size n of your data is large, is far more severe compared to when the size n of your data is small. Remember, in today's world, we will almost never be dealing with a problem consisting of a small data set. So it is very important to choose wisely and choose an efficient algorithm, in other words, a slow-growing algorithm. Or put another way, an asymptotically superior algorithm.